Ladies and gentlemen, would you please welcome Reto Meier.
Good afternoon, everyone. So my name's Reto Meier, and I'm the tech lead for the Android Developer Relations team. In today's session, I will hopefully be able to provide you guys with some tips which will help to turn your good apps into great apps. Now, I consider this to be a follow-up from my I/O session last year, which was Android Pro Tips, making this Android Pro Tips 2 Electric Boogaloo. Like last year, I'm going to try and keep things pretty technical. There will be code. So if you're not comfortable reading code snippets, don't worry. I will give you this signal, which is your cue to put on your headsets, start watching Transformers. So what makes a great app? Well, in my view, a great app is one where users aren't even thinking of it as an app. They're not thinking of, am I using an app on a smartphone connected to the internet over a 3G network? They just want to perform an action. They just want to use a service. Now, whether that's by clicking an icon, selecting a notification, clicking something on the home screen, they just want to get something done. And your app is just the way that that happens. And so the idea here is to make them not have to think about the implementation. They don't have to think about how you've done it, how the device is connected. Everything just works. Let me give you an example of what I mean. A couple of years ago, I had the very good fortune to visit Kenya. Now, over in Africa, mobiles are serious business. And I don't mean serious as in finding the best noodle bar in Nairobi. I mean serious as in this is the only way you get online. I mean serious as in you go to a bar, you see a cute girl or guy, instead of sending them over a few drinks, you buy them mobile phone credits so that they can give you a call if they're interested. Now, if your smartphone is the way you get online, and it's the way that you flirt, a really interesting thing happens to your perception of that device. Let me give you an idea of what I'm talking about. While we were over there, a big part of our G Africa or G Kenya events is finding out and talking about the massive growth in smartphones, innovation and penetration across Africa. So it was kind of surprising to hear that a lot of people didn't self-identify as internet users on their smartphones. And so we asked around, and do you use the internet on your phone? No, not really. Oh, well, that's strange. Why did you buy a smartphone if you're not using the internet on it? Do you not search for things and check your email and update your social networks? Oh, yeah, of course. Of course I use Google and Gmail and Facebook. I just don't really use the internet. So what's going on here? Well, it's actually a really interesting phenomenon. And it's particularly the case in Africa where most people are starting to get online for the first time using their smartphones. So people aren't thinking of these apps as being really efficient ways of displaying a web page on a phone. They're just thinking of that's something I can do with this device. And that's becoming increasingly the case even here, where a lot of the most popular apps don't have websites. And if they do, people don't visit them. The entire experience is on the phone. So how big a deal is this? Well, while we were over in Kenya, we like to visit some of the phone stores to find out what phones are selling, what kind of tariffs, what's the deal. And we found that you could get the same phone on basically the same tariff. And on the one hand, you could get unlimited social networking updates, and on the other hand, unlimited internet access for the same price. And the interesting thing is the unlimited social networking updates was actually a more popular plan. And so what we're seeing is people completely oblivious to the fact that it's the internet that powers this stuff. Now, I'm sure if they thought about it, they would realize, but the key here is that you've made that disconnect. People are no longer thinking about how these things work. It's just something that they want, and updating their social networks is something they do a lot, so that becomes really valuable. So then how do we, as developers, create an app that's more valuable than the internet? Well, it helps if you've already got a service that people really love, a service which they're already taking advantage of, and it's something which they would use as a purchasing decision when figuring out what phone, what tariff, what plan to use. Now, most of us in this room probably aren't in that boat. We don't have the existing biggest service. What we're trying to create is the next biggest service, the next app that everyone has to have on their phones. And I think a really good approach to be able to create that app is to build something that works as though it were an indispensable part of the phone. So something that doesn't drain your battery, something that's not obnoxious, that still provides all the information you need exactly when you need it, but other than that, it stays out of the way. And at the same time, it has to be absolutely reliable. It has to be something that users can take for granted. So they're never asking the question, should I do this? Should I have a fallback? Because if they have a fallback in case your app doesn't work, they're just going to start using the fallback instead. So I'm going to look at each of these topics, invisibility, efficiency, and reliability, in more detail throughout my session here. And so if I seem a little bit nervous now, it's because I've got a video queued up. And if you saw my session last year, I had a little bit of trouble there. So it's with a small amount of apprehension that I queue up the first of these interstitial videos. Thank you. I can't take any credit for the videos, but thank you. So invisibility. So it's obvious why the Droid wants to be invisible, but why do we want to make our apps invisible? Is this something we want? Well, I think it is, and let me explain why. So two things happened to me at about the same time. I started working for Google, and shortly before that, I got my first Android phone, a T-Mobile G1. Do we have any G1 owners, past or present, in the crowd? IO audience never disappoints. Excellent. You've all been upgraded today, so that's wonderful. So those two things happen. And so as you all know, the G1 had the Gmail app, wonderful app. What you may not be aware of is that when you start working at Google, you start receiving email at a rate of around 1,000 messages a second, give or take. And so to try and triage that fire hose of information, I would check my email every morning as I commuted into London from Wimbledon along the district line. So if you've ever had the pleasure of enjoying that particular journey, you'll know that your internet connectivity goes from kind of spotty and intermittent as you go in and out of tunnels and stations until you get to Earl's Court, London Underground proper, and your internet connectivity disappears entirely. Now, the beauty of the Gmail app is that I'm totally oblivious to this. I'm checking my email, I'm reading them, hit archive, it disappears, send a message, and it goes. And I never have to think about whether or not I'm connected. By the time I get back to my desk, open up my laptop, my inbox is synced, my sent messages have all been dispatched, I'm ready to go. And I've never had to think for a moment, how does Gmail work? How is it sending my emails? Is it connected to the internet? Now this is in direct contrast to a lot of the news apps that I'd be trying to use at the same time. So I could see the headlines easily enough. But if I was to click one to try and read the article, if I happen to be in a station, it wouldn't load, or if I go through a tunnel, then I'll get about halfway done, and it'll stop. And so I'd be lucky if I could read more than one or two articles by the time I got into work. And that's the same kind of frustration as I feel when I navigate to a location, and then I look up the venue in an app, and as I'm walking down the stairs, I go to check in, and it's telling me, you don't have an internet connection, so you can't. Try again later. It's like, well, I'm going to go eat dinner now. I'm really not going to bother. And straight away, I've had this disconnect. Suddenly, I'm thinking about, how does this app work? OK, it needs an internet connection, and I'm indoors now, so I don't have a cell connection. I should try and get Wi-Fi. And it's a total disconnect. It makes me have to think about how the app was written instead of what I want to do, which is simply check in. So how do we create apps which are invisible, which let us completely ignore how they're put together in the same way that Gmail works? Well, the solution is to use something like this, a queue and send pattern. Now, the thing about this, so let's have a look at this. Before I go into the details on the code, please note that all of the code, snippets, slides, and everything else will be made available within 24 hours of this, so don't try and copy any of it down. But let's have a look at the code. So what we're trying to do here is we check to see whether or not we're connected. And if we're not connected, as in this case, then we're simply going to add our transfer to the queue. So in this example, we're looking at a check-in. So if we're not connected, that's it. If we are connected, so looking at this next section, then we're going to try the check-in first. If the check-in fails, then we're going to add it to our retry queue. Once we've done that, we're going to go through that retry queue, which includes anything we've queued up beforehand when we weren't connected to the internet, and anything which has previously failed. Anything that succeeds, we remove it from the queue, and then we check to see whether or not there's anything left in that queue. If there is, then we're going to need to try this again later. Now, in this instance, I've created a fairly simplistic retry mechanism, which is just going to use a set interval to continue to retry. Now, this isn't particularly efficient, and I'm going to give a much better example later on of how you should probably do this. But for the purposes of this code snippet, it gives you an idea of the process of what you should be doing. Note also up the top here, when we're not connected, we're also going to cancel this retry alarm, because there's no point waking the device trying this again if we don't have an internet connection. And similarly, or in relation to that, we're also going to enable a manifest receiver, which is going to listen for connectivity changes, so that when we do get back on the internet, we can straight away go through this queued up queue and perform all of those transfers straight away. So you don't have to wait for the user to initiate another action first. So that's one way of being invisible. Another approach is to make sure that your app feels consistent with the rest of the framework. Now, you want to be original, you want to be creative, you want to have something which people are going to recognize and identify with your app, but you don't want to have to give them that moment of cognitive dissonance when they're trying to figure out how to use your app, how does it fit into the system. So the real trick is to create something that is consistent with the framework aesthetic, but still has that creativity, still has that uniqueness that represents your app. Now, the first step to that is to visit the design site at developer.android.com/design, and that has all of the details you need, both in terms of the specific implementation details as to how you should make your apps work, but also the philosophy behind it. So you can think more about how are the Android designers thinking? How have they come to those conclusions? Now, I'm not part of the design team, so I'm not going to go in at any length here, but happily, they will all be here tomorrow, basically all day down in room 9, giving sessions, interactive code labs, all of those sorts of things to try and really help you guys get a feel for how they think, the decisions they've made, why they've made them, and how you can create something that, as I say, is unique and identifies your app, but still allows users to understand how they work without having to spend a lot of time on it. So what else can we do? Well, I look at some of the most popular apps, and you look at things like Shazam, Instagram, they're hugely successful, and I think a big part of that is because they've created something where it's tightly bound to an action. So whether that's recognizing what music is playing or taking hipster photographs, you recognize that action, you associate it with their particular app. And that's a really powerful thing. That's how you get to that point where people just want to be able to do that, and they don't care how it works. Now, one of the real advantages to building something which has that kind of tight focus is that it makes it much easier to then port it across a variety of different hardware. Now, this is important because the Android ecosystem is huge. You've got this huge variety of devices, both in terms of variations on smartphones and tablets, but also an increasingly wide and diverse ecosystem in general. So most of us have spent a lot of time developing for smartphones, and that's where a lot of our focus lies. Now, smartphones have all of the new gadgets. They've got all the sensors. They've got NFC. They've got touchscreens, gyroscopes, front and back-facing cameras, the works. And so it makes sense to develop your app to take advantage of all of that hardware. But then what happens when new hardware comes out? You've all got a Nexus 7. You've probably noticed it doesn't have a back-facing camera. So what does that mean to us as developers? Well, the easiest step is to say, well, my app takes advantage of all of these different sensors. So I'm going to add lines to my manifest which say, well, it requires a touchscreen and it requires accelerometer and NFC and everything else that I take advantage of. But then someone releases a device which is slightly different, and suddenly your app isn't going to be available in Google Play. And you're cutting off what could be a significantly large portion of your potential user base. Now, you want to avoid this. And so let's have a look at a couple of examples. So if you've got something like an accelerometer, something like a compass, which depends on an accelerometer to figure out which direction you're facing, it's perfectly reasonable to say that that is a required hardware feature. But what if you have an app which lets you apply filters to photos? Do you need a camera for that? Well, most of these apps, you don't, because you can apply those same filters to photos that are already on the device, or that are in your gallery. But by simply adding this requires users feature to your manifest, or even in the case of camera, just using the user's permission and not saying that the camera is optional, will prevent that app from being available to these devices. And so a much better approach is to use the package manager to see what hardware is actually available at runtime. So rather than blocking your app from potential users, what you're doing instead is saying, well, the user experience is going to be different. So that could be something as simple as saying, well, if there's not a camera, then I'm going to disable or even hide, remove the take a picture button. That makes sense. But it could be something much more dramatic. And so you may say, well, if there's no touchscreen on this device and no sensors, then I'm going to try and present more of a lean-back experience, something where I'm expecting people not to interact with this app as much. And so by using this package manager class at runtime, you're able to figure out exactly what hardware is available and really customize that user experience to present the best possible way of being able to do things. It really comes down to, rather than trying to say, how do I lay out my screen on these different sized devices, instead, what you're figuring out is, given this hardware, how can users best perform the action which they're expecting to be able to do with my app? So it all gets back to this simplification, making it invisible, making it more accessible for your users. So that's invisibility. I'm going to move on to the next section now, and I'm going to spend a fair amount of time on this because it's a topic that's really close to my heart. I think efficiency is really important for users. So let's have a look at the video. So efficiency. We all know that efficiency is important. It's one of the key tenets of good programming. So it's a huge topic, and today, really, I want to focus specifically on efficiency in terms of improving the battery life of your apps, or reducing the impact on the battery life from your apps. And even more specifically, I want to look at how your use of the cell radio, so the way in which you transfer data, can impact on your battery life. Now, you guys already know about my email habit. I absolutely require email access all the time. And if you add to that apps like Pandora, Google Music, Maps, all the other things which I take for granted, if I don't get 8 to 12 hours of battery life out of my phone, it's a serious inconvenience. I can see a few smirks in the audience. You're thinking 8 to 12 hours? Is that a jelly bean feature? Are you running Cyanogen? It's none of that. Really, the way I achieve it is I'm absolutely brutal when it comes to removing apps that disproportionately drain my battery. So if I install something, look at it once, and then find that at the end of the day my battery life hasn't lasted as long as it did before, I'm going to remove the app. Doesn't matter how useful it is, it's making my entire phone less useful. And so it's going to go. And when you're performing that analysis, figuring out which apps are the worst offenders, it turns out that the way that they use the cell radio is actually a big impact. And you can see that. When you've got your cell phone on and you're using cell data, it can be a significant battery drain. So how do we impact that? How do we reduce the impact of that battery? And a big part of that is quite simply transferring less data. So smaller payloads, less frequent updates, just generally send less data. Now I'm going to look at a few specific techniques for improving that side of things as well. But first, I want to think, is there anything else we can do? Does the timing of your transfers impact the battery life? Turns out, happily for the length of my talk, that the answer is yes. It can impact it, and it results in a scenario that I like to think of as the cookie droid conundrum. So like the cookie droid, we need to think to ourselves, would we prefer one big cookie or lots of little cookies? Or to put it in slightly more practical terms, do we want to have lots of little downloads so that we're only downloading data that we absolutely need, never downloading anything we don't? Or do we have one or as few downloads as possible, or we're downloading lots of information, potentially more than we need, in order to have fewer downloads overall? So let's have a really quick straw poll. Who likes one big cookie? All right, and who's into lots of little cookies? All right, and who thinks we should just go like the cookie droid and eat all the cookies? Yeah? Sadly, my metaphor does not extend that far, so we're going to have to look at the two remaining options that we have. So the little cookie, at first glance, seems like a fairly good approach. You're not going to download anything that you don't need, so you're minimizing bandwidth. You're not processing anything that you don't need, so you're going to save some power on the device that way. And really, what it comes down to is you're going to put everything off until the last minute. You're not going to do anything until you're absolutely certain that you need to do it. And that's an approach that I used pretty extensively getting through college. Now, as it turns out, both in terms of college grades and in terms of cell radio efficiency, it's actually not a very good idea. It's just going to cost you more in the end. And a much better approach is to use this big cookie model, minimizing the number of times that you touch the network, the number of times that you have to perform these downloads. And to understand why that is the case, you need to understand a little bit about the way that the cell radio works. So this is a really simplified version of a typical 3G cell radio. And it works this way. So you start off in standby mode. And every time you try and start a new connection, transfer data, it's going to take around 2 seconds. This varies, but around 2 seconds to bring the radio up to full power, at which point you can start transferring data. Now, if this is a browser, you can imagine this isn't a great experience. If every time you click a link, hit refresh, hit some JavaScript, you need to wait 2 seconds before the radio powers up, and you can even make the request, let alone download the data, let alone render the data. And so to try and account for that, the cell radio will stay in a full power state for some amount of time, typically somewhere between 5 and 10 seconds, and what we call a tail time. So within that time frame, the radio is still kept in high power state, so you have no latency if you want to perform further transactions. After that tail time has expired, you go into this low power state. It's going to draw about half as much power, and the latency is going to be reduced. It's still going to be there, but it's going to be significantly reduced. Now, we're going to stay in that low power state for somewhere between 10 seconds to a minute. And again, if nothing happens after that period of time, we go back into standby state where we're not drawing current, but we've introduced this latency. Now, the specific tail times are going to vary based on carrier. So that's going to be not just carrier, but also location, so east or west coast, different countries, different carriers, different usage patterns for their customers and everything else. And so AT&T has timings which look like this: 5 seconds for high power tail time, 12 seconds for low power. Vodafone has also 5 seconds for high power and a full 30 seconds. Now, I should point out that there's no better or worse. These are just different ways in which these companies have figured out the most efficient patterns for their users in those locations. And it goes on, and you can imagine it's the same for Verizon and T-Mobile and everyone else. So how do you then, as a developer, figure out the best frequencies, the right timing to do your downloads in order to have minimal impact on the battery? Well, everyone here is an engineer, so I assume everyone's familiar with fast Fourier transforms. So we're going to start with this basic equation, and then what we want to do is for each carrier, find the square root of the sum of the squares of those delta tail times. Divide that by pi. So who's still with me? Got a couple? It's very impressive because this is totally made up. So if you guys could see me afterwards and explain, that would be fantastic. So like I said, this is irrelevant. It doesn't matter. It doesn't matter what the different tail times are. It doesn't matter what the variation by carrier is. All you need to know is that every time you touch the internet, every time you make a connection or do a transfer, you're potentially going to continue draining battery for a full minute. Just think about that. So if you touch the internet just to do a ping, just to say, yes, someone is still looking at this page, the cell radio is going to stay on and continue draining battery for up to a minute. This is much easier to understand if you have a look at the visualization. So what you have here in blue, the blue line graph represents network traffic for my app. And so you can see the little periodic updates about every 15 seconds. And then we have these larger sort of intermittent transfers. So this could be a news app where the periodic transfer is analytics. We're keeping track of what page, what articles people are reading at all times so that we can get a feel for what the most popular news articles are. And the intermittent transfers, they may represent someone clicking an article, right? So they want to read the full text, so you click that, you download it, display it, and they read it. Now what's more interesting is underneath, and that represents the cell radio state. Now blue is an active transfer, so this is when we're actively sending and receiving data from our server. Red is that tail time, that high-power tail time where the radio is still drawing full current, but we're not actually transferring anything. And that will last for around 5 seconds. And we're in this instance exactly 5 seconds. So you can see right at the beginning, it was on, and then we've started another transfer straight away. So it's continued in that high-power state. If 5 seconds elapse, it'll turn yellow, and that's when we're at that low-power state. And it'll stay there for a further 10 seconds, assuming that no one performs any transfers. Now, once that time has elapsed, you'll go back to the idle state, and that is represented here in green. Now, you probably noticed the problem. There is no green, right? So the entire time that this app is running, it's drawing power from the battery. And you can see it gets worse than that, because even just this section in the middle, where it's just the periodic transfers, we're still never going green. So even without the user doing anything, you're still going to be drawing current, reducing your battery life just by having the app open. Now, this is exactly not what you want. So how do you solve this problem? Well, I like to think of it as defragmenting your network traffic. And what we're really trying to do is use a combination of different things. Prefetching, bundling, basically trying to perform this big cookie model, do as many things as we can every time we touch the internet, so that we reduce this intermittent touching, so we have less and less time spent draining the battery. Now, I'm going to explain how you can do that, but first of all, I just want to show you exactly what I'm talking about. And this is the same data being transferred, the same amount of data, but everything has been batched together. So those periodic pings, those analytics updates, I've just batched them up. And I only send them when I have something else that I need to do, because when they get sent isn't important. Now, instead of having on-demand downloads for the news articles, I'm going to prefetch them. Now, I wrote this app, and I happen to know through my analytics data that people read exactly 2 articles every minute, and I happen to know exactly which 2 articles those are. So that's made it really easy for me to be able to do this prefetching routine of 2 articles a minute. Now, this is pretty contrived, but it's actually contrived in a way that makes it not as effective as it could be. In a real-world solution, you can have this window extend far further than the few seconds that I have here. But even with this contrived and basic solution, you can see the impact is pretty dramatic. Straight away, you've gone from having no green to having almost 2/3 green. And even the active traffic has been reduced because we're able to be much more efficient in the way that we download our data by doing it all in one go. And so we've reduced both the active time and the standby time so that we really are in a much better situation here, where the app is not going to be draining the battery for anywhere near the amount of time that it was before. So how do we create these graphs? How do we figure out what our app is doing and how to make it better? Well, there are a number of tools available for doing just that. On the most basic level, you can use logcat. So you can just print log statements before and after you've started doing your transfers, potentially even keep track of how much data you're transferring each time in order to build up these graphs and this idea of how your app is behaving. Another option is the Arrow tool, which is a free open source tool available from AT&T, who I think are actually demoing it out in the sandbox, so you should stop by and say hi to them. And the advantage of their tool is that it's going to produce graphs very much like the ones I showed in the previous slide. So they're going to show you your network traffic, and they're going to overlay your radio state, specifically the AT&T timings. Another approach, which I actually quite like, and this is more recently available, is the Network Statistics tab in the DDMS view of your Android developer tools. And that's the output that you can see here, so this colorful graph. And so this lets you tag different sockets, different parts of your app, so you can see how they're all interacting, as you can here using different colors. And you can do that using the traffic stats class. So this is a relatively new class. The beauty of all of this stuff is that you can use it on your app, even if you're targeting early versions of Android. You can do this analysis statically in the emulator. So you can do this for, no matter what your target is, even if you're not targeting later versions of Android, you can still perform the analysis. So the way this works is you simply assign a tag to each of your output sockets. and then they're color-coded, and you're able to see exactly how your app interacts with other components within itself, and you can look out for certain patterns, which I'm going to go into a little bit more detail on. If you're not using sockets directly, if you're using a HTTP client, then you can simply set the thread stats tag on the thread itself, and that will automatically be assigned to the socket used by that HTTP client, making life a little bit easier for you. So now you've got the graphs. The next step is, what are you looking for? So the first thing you're looking for is these short spikes. So this represents, each of these spikes is 1 second. And so we're looking for both short in terms of height and in duration, particularly duration. Because here, we're downloading for a second. And each time we do that, the device is going to be drawing battery for a minute. So that's a really bad deal. So you want to look for anything like that. And typically, these are going to be good things which can be delayed. They can be bundled up. They can be queued so that you can download them all in one go later. Another really bad sign is anything periodic, anything which is happening on a set basis, because this stuff is basically guaranteeing a minimum amount of time that your app is going to be drawing power. Now, that's not what you want. The minimum possible time that your app should be drawing power from the cell radio is 0. The user is doing nothing and hasn't done anything, it shouldn't draw any power. And so this is a really bad sign. Slightly less concerning, but still an area that you can look to improve, is these batches of activities which happen in close proximity. And so here, they're not unreasonable transfers, but there's this gap. There's this few seconds between each of them. And in that gap, we're still drawing battery. So just by pushing them together, we can have that incremental improvement. So let's have a look at some solutions. What can we do to try and improve this, to defragment our traffic? And one of those approaches is prefetching. Now, what you've got to remember is that when the cell radio, when the carrier are working out what is the right timings for these tail times, this is what they're trying to balance. They're trying to minimize the latency and minimize the battery life, but one plays off against the other. So they don't really have a choice. This is the graph that they're on. Now, from our perspective, from our user perspective, this is exactly the wrong graph. We don't want that. What we want is to hit this sweet spot, where we've got basically 0 latency and maximum battery life. That's what we're trying to achieve. Now, the beauty of prefetching is that you kind of get the best of both worlds. If it's already downloaded, it's already processed, then you don't need to wait for it to process it again. And at the same time, if you've prefetched it, if you've bundled everything together, then you're not getting this spike, this intermittent download in the middle of your app's lifecycle. It's already there, and you can much more closely manage the frequency of those downloads. Now, unfortunately, prefetching isn't a silver bullet. There is a risk. There's a risk that you're going to download a bunch of data that you don't need. And that's going to drain the battery just as efficiently, or just as effectively. So how do you make that balance? Well, generally what you want to do is make sure that whatever you're going to download is going to be used by the app. What you're trying to avoid doing is downloading something that you know you're going to need later, so you do it ahead of time. Now, typically, that's going to be somewhere in the realm of 2 to 5 minutes. Now, this depends on your app, the way that it's used. So a lot of apps have sort of this 2 to 5 minute window where they expect people to use them. If you've got something like a music player, that window may be significantly longer. And the amount of data is also going to vary. So it's usually somewhere around 1 to 5 megs, but this is going to vary based on the cell radio technology, its effectiveness, as well as your app. So practically speaking, if you've got something like a music player, you probably want to download the currently playing song in its entirety, and probably the next song as well, but probably not the playlist, probably not the album, right? If you've got a news app, you can be a lot more aggressive, because we're talking about text, and text is cheap. So you can download heaps. You can download all of the headlines in all of your categories. And you know what? You should probably download some of the article text as well. Now, you can either do this simplistically and just say, well, this is my front page. I'm just going to start prefetching things based on when they appear to the user. Or you can be a little more clever and use analytics and say, well, 70% of the people who use my app read these articles, so I'm going to prefetch them for everyone. Or make it more personal and say, well, this user always reads all the sports articles, so I'm going to pull all of them down. Really, it's just a matter of trying to figure out what is most likely to be used so that I don't have to pull it down later without pulling down things which isn't going to be used. And I mentioned that this was for 3G, those specific timings. And the thing is, it changes depending on the cell radio that you're using. They have different efficiencies, they have different speeds. So in this example, we're going to start with a default based on a 3G network radio. And there's a lot of code here, but it's effectively just a couple of switch statements. And all we're doing is checking what is our network technology. If it's 4G, then, well, we've got two things at play. These radios, they tend to drain a little more battery than their 3G equivalents. They're also faster, so you can download more over the same time period. So if you're trying to balance the cost of the device is going to be drawing current for a minute, so I want to download for at least 10 seconds, you want to download more on a faster network. And the reverse is true for 2G. So it's slower, it's slightly more energy efficient, so you want to download less data. Now, the specifics, so I've gone ×4 ×2 is kind of arbitrary. This is something that you need to figure out for within your own experience what makes sense for your data and for your app. But the key here is to remember that it is going to vary. And it's especially the case with Wi-Fi. So on Wi-Fi, you don't have a cell radio cost associated with performing these downloads. So you can be much more aggressive. And in this example, I've simply said, download the maximum amount that we can to put in our cache. And this is going to be much more dependent on how much data do we want on the device, what's the relative cost for processing it, rather than the cost of putting things on the network. So that's fine for apps, for data that we know we're going to need. So if you can prefetch things if you know eventually it's going to have to happen. But what do you do about things which happen, which are user-initiated, things which you don't know you're going to need ahead of time because they're going to change or because the user has created them while they're using the app? And the key here is to try and bundle them all together so that you're trying to be as efficient as possible. You're bundling them, you're batching them, you're doing whatever you can to try and ensure that they aren't draining the battery when you don't need them to. And one solution for that is to use a batch queue for anything periodic. So this is for things which are user-created but aren't time-sensitive. So analytics are a great example of this. Anything where you don't need the server to provide you a response, you just need to upload it at some stage. They work really well here. And so you can see in this example, what we're doing is every time we have something periodic which we want to send to the server, we're going to add it to a queue. And then we're going to execute that queue at a certain point. And you'll note, importantly here, that when we do execute that queue, when we transfer all of these bundled periodic transfers, we're also going to execute the next prefetch. Now, that may not be scheduled to happen for another minute or two, but hey, we've got the radio turned on. Why not, right? Do it all now. Get it out of the way, and then we don't have to turn the radio on again later. The same thing is true when you have time-sensitive on-demand transfers. So when your user is uploading a photo, or if you want to get some feedback directly from the server, it needs to happen then and there. But that's no reason not to bundle everything else together as well. And so when you do have these time-sensitive transfers, you execute the next prefetch. And when you do that, you execute all of your periodic transfers as well. So it all comes back to the same underlying philosophy. Every time you touch the internet, do everything which you think you may need to do for the next few minutes at once. So that's all good and well, but what happens to the data that is server-side, but you still need to get regularly updated? So you have a news app, and you want to get new headlines, or a weather app, and you need to know what the current temperature is. These are things which traditionally you're going to do by polling. So how can we make this a more efficient process? Fundamentally, we want to make it less frequent and less regular to try and get away from these bad patterns that we've seen earlier. First thing we can do is everyone's favorite inexact repeating alarms. Wouldn't be I/O if I didn't present this slide. Basically, this is going to let the framework do what we've been talking about for us. It's going to phase shift our alarms so that all of our downloads happen at the same time as other apps' downloads around a similar time frame. So rather than each app waking up the device every 5 minutes, it all happens at once. So this is a good start, but it's pretty simplistic. So what else can we do? Well, one approach is to use what I think of as an inactivity back-off. So what's happening here is we're going to set a default for how often we should do our background updates. Now, if you've had to do this, you know that this is a balance. This is a payoff where you're thinking, how frequently can I do these updates so that the data is as fresh as it can be, but we're not draining the battery by updating every 5 minutes in the background? So it's always this balance. What I'm suggesting we do here instead is to say, well, let's start with that. But if the user doesn't open the app since the last time we've done a refresh, well, that was wasted. So let's wait twice as long next time. If they still haven't touched it, wait twice as long again, and so on and so forth. So what you've created is this dynamic solution where if the user is constantly using your app, they will get fresh data. If they aren't, if they open it once, exit it, and never look at it again, hopefully that's not going to happen. But if it does, your app isn't going to drain the battery. So they don't have a reason to uninstall it. And so I think this is a really good alternative to trying to create that sort of that solution where you're trying to find that balance. So that's something we should definitely consider as a default. And obviously, it's always useful to have an option for users to manually set their refresh frequency and say, well, actually, I want it to be more or less frequent than this. But this is kind of a more efficient way of being able to do that first step. So I also mentioned early on that my retry mechanism was overly simplistic. It was inefficient, and I learned this the hard way. So a few years ago, I built a widget for Google Desktop. Anyone remember Google Desktop? A couple? Nice. So what this did is scrape the Cricinfo website to get test match cricket scores. And as everyone knows, the fate of a match can hinge on a single ball. So I had a very aggressive update frequency of every minute. Every minute I would hit the server, scrape the web page, find out the score, and then I would look for a little string which said that the match had completed, at which point I would stop doing my updates. And this worked really well, except that I had a friend of mine who was beta testing it at work, and he went home on a Friday before the match had finished, and then by the time he came back on Monday, he got the 404 page. That's a pretty busy 404 page. In fact, it's 131K of 404 page, and I was hitting that every minute, every hour, every day. So after a week, we've got 1.25 gig of download, which he discovered when the NetOps team came past his desk to see if he was doing BitTorrenting. Now, imagine this on a mobile device, 4 gigs a month. That sounds, well, 5 gigs a month. That actually sounds a lot like the fair use quota for a lot of tariffs. So this isn't good. Even if you have a much more simplistic 404 page, or just an API which returns with an error code, your data is going to be a lot less, but you're still doing these periodic updates. You're still going to drain the battery just so that your app knows that something isn't working. Not a good approach. Solution here is that same back-off, an exponential back-off. And here I'm doing it using a recursive algorithm. For your apps, you're probably going to want to use something like alarms to do the same thing. But the key here is that if it doesn't work, just wait twice as long next time and keep extending that. On a phone, you probably want to get to that maximum interval and say, you know what? It's not working. Forget it. Show something to the user, do something within your app to account for that. But there's no value in continuing to try something that clearly isn't working. Now, what's a better alternative to all of this background polling, trying to make that more efficient, is to use Google Cloud Messaging instead. So this has been re-released now. This lets you eliminate polling completely if you have control over the server. So you just register your device to your server and to Google Cloud Messaging, and then from then on, instead of you polling the server sends your device direct messages whenever it has something that it needs to update. This is so much more powerful because you're no longer trying to figure out that balance between how often should I ping the server to check if there's something there in order to provide fresh data. You just get told by the server when there is new data, and then you can make a decision as to, do I want to download that now? Do I want to wait until our next prefetch interval? What is that data? You can send all of that information and provide a much more efficient solution. So I'm not going to go into too much detail. The key to it is that it's available all the way back to Android 2.2, which is like 94% of devices. And in addition to all of these new features, it has a significantly simpler authentication story using API keys. So it's much easier to use on the server side if you're not a server-side developer, which I'm not. So this was a big thing for me. It's actually the next session down in room 9 downstairs is all about Google Cloud Messaging. So if this is of interest to you, and it really should be if it isn't, definitely go and check that out. So this kind of goes without saying. I'm going to say it anyway because it seems fitting. Redundant downloads are redundant. Don't download anything which you've already downloaded. There's a few ways you can do that. So you want to make sure that you filter anything on the server. Use APIs, which are going to let you say, this is the last piece of data that I got, or this was the last time I did my update, so only send me things more recent than that. So that's kind of fundamental. Then you're not having to process things, you're not having to download things which you've already downloaded in the past. And the same thing goes for any processing that you're going to do on all of that data. If you download an image, and you're going to display it as a 72-pixel thumbnail, there's probably no reason to download the full wallpaper. It's much easier, much more efficient for you to be able to do that stuff on the server. It's much easier to throw resources at a server-side solution than to try and hope that all of your users are going to buy faster, better phones. So anything you can do server-side, do it server-side. And when you have downloaded it, make sure you cache it. Cache everything. You've got a couple of alternatives. You can store it in the external cache, and now this, I think, requires a new permission in Jelly Bean to write to the external storage. And it's also world readable, so it's kind of not awesome. If you use the internal cache, that's going to be within your application sandbox. So it's going to be controlled by you. It's going to be also managed by the system, which means that if it comes under resource pressure, it's going to be able to clean out your cache in order to be able to save it some room. So this is kind of the best approach. Another thing you can do is make sure that you don't download anything that you don't have to. And so you can do that by inspecting the headers of your HTTP responses. So you can check, when does this data expire? When was the last time it was updated? Do I need to download the body here? When should I try and update all of this information? And so that can be really useful. Even better is that in Android 4.0, we introduced a HttpResponseCache to the HTTP URL connection class. And so this is just using reflection to turn on a 10 meg cache on a HTTP URL connection. And what this does is it's going to do all of the stuff that I just explained for you. It's going to create its own cache. It's going to inspect the expires headings. And every time you make a request, it's going to check to see whether it already has that data and whether or not it has expired. And if it has it and it hasn't expired, it's just going to serve you from the cache. And it's going to put it into the cache automatically for you. So this is a really neat trick to be able to take away a lot of that hard work from you. So that's almost done with efficiency. If you want to have all of this information without my strangely monotonic Australian accent in much easier copy and paste code snippets, then you can get it all from the developer training site at developer.android.com/training, and it'll all be there for you. I've spoken in this section about efficiency, specifically about battery life, specifically about the cell radio. Jeff Sharkey is going to be doing a session in this room at 4 o'clock today, which is going to cover a whole bunch of other efficiency things you can do with CPU, with memory, with I/O. So definitely check that out. So we have a few minutes left. We've got one last section, and this one will be the shortest. So reliability. Reliability is an obvious thing that we all want. And it's something which you want to be able to take for granted. So if your power stops powering your devices, if your water stops running, it's kind of a big deal. But if it works, you just totally ignore it. And that's exactly what you want. You want to be able to take these sorts of things for granted. And so how can you do that? How can you create an app which is properly reliable? So part of that is static analysis. So you can use tools like lint, like strict mode, which will let you have a look at how your apps are working. I kind of like to think of these as a lot like a peer review. Someone who already knows all of the right stuff, probably the same stuff as you, maybe a little bit more, and they're able to give your code a look over to tell you whether or not you're doing the right thing. Now, so it's basically a peer review, but without the self-loathing and recriminations that so often accompany a good peer reviewing. Once you get past that, though, you really need to see how your app is going to work on devices, and that means buying devices. Now, there's thousands of Android devices, and certainly no one is going to expect anyone to buy all of them. Certainly, Google hasn't. So what is an alternative solution? Well, one thing which we found from talking to developers trying to solve this problem is to try and find ways to separate that market. Now, what I've done here is separated into buckets in terms of screen size and screen resolution. Now, this is no longer the way that you should be designing your screen layouts. So you're not trying to design screen layouts in terms of these buckets. You're trying to use minimum screen widths and make sure that you create an app that scales within those bounds. But in terms of choosing apps, choosing devices, I should say, to test your apps, this is actually still a pretty good approach. So you're now down to 16 buckets. And as you choose each of the devices from that, you want to try and create something that is as varied as possible. So you want to get devices with different GPUs, different manufacturers, some which have cameras, some which have slide-out keyboards, touchscreens, et cetera, et cetera. And that'll give you a really nice cross-section to test with. That's kind of still a lot of devices. And so if your budget's a little bit more limited, you can kind of focus on the areas which are going to represent the largest part of your audience. And so you can see here that that pretty much comes down to smartphones and 10-inch tablets at the moment. So this is based on the numbers on the Android developer site. And that'll give you pretty good coverage, right? And that's only 3 devices. The only problem here is that you're actually possibly limiting yourself. What comes next? I mean, this is the devices that are out there now. But, well, you all have Nexus 7s now. And at $199, I kind of get a feeling there's going to be a bunch of these devices in people's hands. Plus, all the new smartphones are running XHDPI. So the Galaxy Nexus, HTC One X, the Samsung Galaxy S3, they're all running these extra high-res displays. And so while this is a little bit of guesswork, you can usually take a pretty good guess as to where the next big buckets are going to be and perhaps invest in those as well. Now, you guys are lucky because you already have those last 2 buckets given to you today. So that's going to make life a little bit easier. So you've done your testing on your hardware. I did mention that that's not the right way to do multiple screens. The right way to do multiple screens is also on the developer.android.com training site, so do check that out. Beyond that, for the devices you haven't got, use Monkey Runner, use the emulator, try out as many different variations as you can. And also, get people to test it for you. Get alpha testers, get people who you know, and don't get your smartest, techiest friends, get your least techie friend, the guy who you have to help him get his phone out of Swahili every other week. That's the guy who's going to find the edge cases, who's going to try and press 7 buttons on your screen at the same time and wonder why it broke. That's the person who you want testing your apps. So, if there's anything we've learned from I/O this year and from the keynote yesterday, it's that Android is really a lot more than just a smartphone development platform. Certainly, the huge, huge user base of smartphones means that it's going to be the focus for a lot of us. But with new devices like these tablets, like the Transformer Prime and the Nexus 7, we're seeing this increasing ecosystem. And if you guys have had a chance to hack around with the Nexus Q, you'll see that the potential is that this ecosystem is going to grow even further to devices which are more and more varied, more and more different. But fundamentally, hopefully, if you create an app that uses the achievements of invisibility, efficiency, and reliability, you'll create something so that it doesn't matter what users are using, which device they're operating with. They're not using the internet on their phone. They're using your app. Thank you. So then we barely have enough time for a couple of questions, but before we dive into that, I just wanted to give a quick rundown of what I used to provide this presentation today. So I got a lot of questions about that last year. So I'm actually using 2 devices over here. So I've got a Nexus 7 and a Transformer Prime. And I've hooked them up so that the Transformer Prime is doing all of the work. So I've got a HDMI cable which goes up to the projector. My clicker plugs into it. It's got an internet connection to send off stuff to the social networks. And I have a Nexus 7 over here, which is where my speaker notes are. And today, actually, they hooked it up, so it shows up on my confidence monitor down there. So yeah, we do have a couple of minutes. So questions? There's mics, I think, down the aisles on both sides.
Check.
That's on.
Thank you for your presentation. And I'm Bo Stone from Bo Stone Consulting. So here's the question. Is there an easy way to detect that the radio is in fact on? And so would it make sense to check that before I do that batching that you were referring to?
That's a good point. So that's definitely something which would be useful, but no, there aren't any APIs at the moment which allow you to say, perform this the next time the radio is on. You basically want something like the passive location provider, but for transfers. Unfortunately, no, there's no API for that at the moment.
So maybe you guys will add it in the future.
That's definitely something to hope for.
Thank you.
No problem.
Hi.
Hey.
Can you comment on the CPU and battery life trade-off of compressing a text file before sending it versus sending it uncompressed?
That's a good question. So I think the battery life impact on doing that compression is going to be pretty negligible. So the processing cost of that is going to be pretty slow, whereas when you're doing that transfer, like, not only is it going to be a shorter amount of time that you're sending it for, but it's also going to mean less pressure on the networks themselves. So a big part of this as well, like I focused on the efficiency side, but if you talk to any of the carriers, like it's really important for them to get those payloads as small as possible, let their networks work more efficiently. And that's going to end up in a much better result for your users as well.
Thank you.
Of course.
Hey, thanks for the presentation. Regarding the earlier part of the presentation, do you have any idea if Google Analytics pays attention to sort of all your recommendations or the big cookie?
That is a good question. So I think the existing analytics SDK allows you to dispatch your analytics information whenever you want to. So that allows you to have that control. And I think it's something that I've just actually been having conversations with them now to find out exactly what they do and what they don't do in terms of automated downloads. So it's definitely something they're aware of, and yeah, we'll go from there.
Cool, thanks.
Of course.
Hi, my name is Rob. I just want to know if the HTTP response cache class is useful for caching images or just for small HTTP responses, because I find caching images, especially with like downloading background threads to be a really challenging problem when you're downloading a lot of things at once.
Yeah, absolutely. So downloading images is definitely a challenge. I would say the HTTP response cache, I had to practice a long time to be able to say that. It probably could work, but you know, it's probably not the most efficient way to deal with that. So there's, I think we talked in the fireside chat yesterday about the fact that there is a library which we will be releasing at some point, which tries to do that in the most effective and efficient way. And I think there's an Android training class as well going around that.
I am really looking forward to that library.
Yeah, I think you're not the only one, yeah.
Hi. So you recommend to use cloud messaging service to push messages, right? But
Yes.
I'm wondering, so basically a little percent of user will not sign into any the Gmails, right? So those, what is the plan for those little percentage of user? Like for example, 2-3% user, they don't sign into any account, right? So what is the plan that how we can push messages to those little percentage of user?
That's a good question. So I'm not 100% sure on the answer here. So you'll want to check with the GCM team who are doing a talk next. I have a suspicion that GCM doesn't require a sign-in. It just requires the GMS services to be on the device, but the user doesn't need to sign in,
so
I think.
You mean to say this would be different from C2DM? Because C2DMs surely require user sign into.
Yes, so C2DM did, and like I say, I'm not certain. So please do check with the team. But I have a suspicion that may have already been solved.
So maybe you can give me some contact.
Yeah, absolutely. Like come out to the office hours, and we'll hook you up with the right people.
Hi, Reto.
Hey.
Great session.
Thank you.
Are you aware of the Google HTTP library, which also does stuff like exponential back-off, retry handling, e-tag caching, and would you recommend that for development in Android? Because I think it's compatible with Android runtimes.
No, I'm not particularly familiar with it, so I can't really comment. But
It's a library from Google itself, so
awesome.
yeah.
That's usually a good sign. But yeah, I couldn't say. So I'd have to look into it before giving an opinion. Cool. All right. Perfect. All right. Thank you very much, everyone.